So, again, I'm looking at the packet, very first part. All right. So, again, we're going to go through this fairly quickly because it's really nothing new from what we talked about yesterday. So, remember, yesterday we talked about the standard form equation for a circle. All right. So, remember, the equation of the circle formula is still on the board. It's in red. If you have a center point HK and a radius of R, the formula will be x minus h all squared plus y minus k all squared, and it's equal to r squared. All right. That's always how it's set up every time. All right. So, let's look at the very first example. So in the grid below of a circle whose center is the origin and whose radius is 10, all right, and it's drawn. So what do we know about the point that lies on the circle? So this point right here, what's so special about it? So here's the center, here's this point. What do we know about that point? Or better yet, what's true about every point that lies on a circle? So if you went around the complete outline of the circle, any point on that circle can be used to create a what? Not necessarily a right triangle, but a starts with an R, radius. All right, so if a point lies on the circle, it can be used at any time to create a radius as long as it goes from the point that's on the circle to the center of the circle. So they can be used to create a radius. Now, I don't really care about B and C. That's not really part of, well, oh yeah, we can. All right. So we already know the standard equation for equation of a circle. All right. We need the center point and the radius. Did they or did they not give it to us? So read where it says exercise 1. Did they or did they not give us the information we need? So guys, close your Chromebooks. You do not need them out right now. So no one should have their Chromebook open. So the center is the origin and the radius is 10. So they did give us the center and the radius. So the radius here is 10. And what's the point if we're talking about the origin for the center? 0, 0. So my center is 0, 0. So that being said, what's my equation of the circle? Yeah, what's the equation of the circle? You got this? Okay. So, equation of a circle, what is it? All you're doing is taking this information and plugging it into this formula, guys. So what's my H value? 0. What's my K value? What's my R value? 10. So we got x minus 0 squared plus y minus 0 squared, and it's equal to 10 squared. So let's simplify that down a little bit. If we're just subtracting x minus 0, what is that actually? Anything minus 0 is always what? The number itself. So x minus 0 is x. So this becomes x squared. Same thing with the y's. We get y squared because y minus 0 is y. And then we still have that squared in play. And then what's 10 squared? 100. So this is our equation of a circle. Now, how do you think I'm going to prove that this point lies on the circle? So there's two things I'm going to use. I'm going to use the point itself, and I'm going to use that equation. So what do you think I'm going to do? Plug it in for x and y. So 6 is x, 8 is y. Now, when we plug it in for x and y, what are we checking for? How do we know if it lies on the circle? So if I plug it in, I got 6 squared plus 8 squared is equal to 100. So what should happen when we simplify that down? If it does, in fact, lie on the circle. What should both sides of the equal sign be equal to? 100. So if both sides of the equal sign are 100, that means we have a true statement, which means 6 and the point 68 does in fact lie on the circle. All right. Now, if we didn't get 100 equal to 100, like say we got 95 equals to 100, it would not lie on the circle because that's not a true statement. 95 does not equal 100. All right. So let's simplify this down. What's 6 squared? 36. What's 8 squared? 64. And again, it has to equal 100. And then what's 36 plus 64? 100. So 100 is equal to 100. That is a true statement. So yes, it does in fact lie on the circle. So based off of that, we are now going to show 7, 7. All right. So we're going to do the exact same thing. So this is x, this is y. We're plugging it into the top equation. So I get 7 squared plus 7 squared is equal to 100. Well, what's 7 squared? 49. Plus 49 is equal to 100. But what's 49 plus 49? 98. Is it true that 98 equals 100? No, it does not equal 100. So this is not a true statement. So does 7, 7 lie on the circle? No. So point is not on circle. All right. Now we're going to skip letter D because that's just kind of implying the whole circle part. All right. But at the top of your paper, I do want you to write what's on the board in red. I do want you to have somewhere that the center is equal to HK and the radius is equal to R. Then the equation of a circle, or the circle equation, would be x minus h squared plus y minus k squared is equal to r squared. All right, so you're basically just writing exactly what's on the board, but in the red. And by that, I mean on the board in expo marker. All right. All right, so if we're talking about equations of circles that are centered at the origin, all right, and again, that means the center is the point 0, 0, and the radius is r. This would be our circle equation. And again, the reason that is, as we saw up here, all right, is because if we plug in 0 for h and k, which is the point for the origin, when we simplify it down, because anything minus 0 is itself, we get x squared plus y squared. So they're basically saying if it's centered at the origin, we don't really need to worry about the whole x minus h. We can just go straight to x squared. Same thing with y minus k. We can go straight to y squared. All right. Now, if you did it like this, I wouldn't count it wrong either, because at the very least, you know what you're doing. All right. So if you just put 0, 0 back into here, that is completely fine. But I'm just letting you know that there is a more simplified version. But honestly, as long as you can write an equation of a circle, I'm happy. All right. So we're trying to figure out if the point 74 lies at a circle centered at the origin. So the point 74 lies on the circle. It does, in fact, lie on the circle, but it's centered at the origin. So they did not give us our radius. But based off of yesterday, what could we do to find the radius? So think back to when we were doing the discovery activity. Not the Desmos activity, but in Delta, when we were doing that discovery guided question. What essentially were we doing at the beginning of it every time? So remember this. If I have a graph of a circle and it's centered at the origin and the point 74, well, I'm going to draw the circle first. But the point 74, which would be somewhere over here, lies on that. So the point 74 lies on the circle. So this is the point 74. So what's a way that we can find the radius? Yes. Right. So one way that we can do that is that if we did rise over run to get to the 7,4, we're essentially going to be creating a right triangle. So let's say that if we create the right triangle, this point would be, let's say 7, 0, which it is. All right. Now, if you don't know that, that's okay. We could also just do rise over run. So let me ask you guys this. If I were to rise upward, first off, what do you think my vertical height would be? How would I get from 0 to 4? Add 4, so the vertical height would be 4. Then the horizontal distance, how far would it be from 0 to 7? 7. And just like that, we created a right triangle. So then what can I do to find the radius? What very special theorem can we use to find any missing side of a right triangle given two sides. Talked about it yesterday. The Pythagorean theorem. All right. So remember, that is a squared plus b squared is equal to c squared. So 4 in this case is a, 7's b. All right. And then what we're finding is c. So I'm going to plug everything in. So I got 4 squared plus 7 squared. It's going to be equal to c squared. So let's work it out. What's 4 squared? 16 plus what's 7 squared? 49. And that'll be equal to c squared. What's 16 plus 49? 65. All right, that's equal to c squared. Now, what's the last part that we got to do? Square root it. So our radius, or let's just call it r, or c in this case, whatever we want to call it, would be equal to the square root of 65. So that's our radius. But it also asked us to write the equation of the circle. All right. So if it's centered at the origin, that means on the left side of the equal sign, we would just have what? If we're writing the equation of the circle. So if we're plugging into the formula here, the center is the origin, and we got our radius. How would I set this up? So guys, it's just a simple plug and chug. You're just plugging it in here. If your center is HK and your radius is R. So if it's at the origin and this is our radius, what's my equation of the circle? Close. You got the radius part right. But remember, it's centered at the origin, so that's the point what? 0, 0. Now, if the center was 7, 4, that would have been the correct answer. All right? But since it's at 0, 0, we just got to replace the 7 and the 4 with zeros from your answer, Gavin. So this would be x minus 0 all squared plus y minus 0 all squared. And just like Gavin said, if you took the square of square root of 65, you would just get a singular 65. And guys, another way you can think about it is if you look right here, it says that c squared is equal to 65. In other words, r squared is equal to 65. All right. And then if we simplify that down to get rid of the zeros, we get x squared plus y squared is equal to 65. So that's our equation of the circle. All right. Now we're going to show that the point, whether or not the point negative 8, 1 is on the circle. So what do you think I'm going to do? We've already done some like this. So what do we do up top when we were checking to see if it was part of the circle? We plugged it in for x and y. So negative 8 is my x, 1 is my y. And what do we want our answer to be once we simplify that expression? It should equal what in order for it to be on the circle? 65. Good. So let's see. So what's negative 8 squared? 64. Make sure it's positive 64. Because remember, negative 8 times negative 8, that gives us a positive number. And then what's 1 squared? 1. And 64 plus 1 is, in fact, 65. Thus, the point's on the circle. All right. Any questions on any of this? All right. Now, the next part, they're saying to use the distance formula. if you're only given 2 points on the circle. I absolutely hate the distance formula. My suggestion to you is put it on a graph and do Pythagorean theorem. So, in my opinion, because distance formula, it's not hard to plug stuff into the distance formula. It's just really hard to simplify it, and there's a lot of room for error. So, we're going to say screw the distance formula. What we're going to care about is that if we have 2 points, so x1 and y1, x2 and y2, we're going to do the Pythagorean theorem. And what that means is that we're going to take, then graph the points and create a right triangle. All right. So let's do a quick graph. And you can draw this off to the side. It doesn't have to be perfect. I can actually change my screen so that it's graph paper, which you probably can't see because it's so light. But just know that for mine, it's going to be fairly accurate. All right. So yes. Mm-hmm. So let's just pretend that we knew that the center is here. All right. Now we know the radius is 5, but let's pretend like we didn't. Let's pretend like they just gave us the center for 2 and one of the points. So let's say 8, 5. All right. So what that's going to look like is on a graph. All right. My center is at 4, 2. So that'll be up 4 to 2. And one of the points on my circle is 8, 5. Hold on. Yeah, we're good. Okay. So we then have the point 8, 5. So we count 8 more and then go up to 5. So I can tell you right now that this point is in fact on the circle. But what we want to do is that we want to prove that the radius is 5. All right. So even though it tells us the radius is 5, we're going to prove that the radius is 5. So we're just going to say we don't care about this part. We're saying that if we have a center 4, 2, and this point 8, 5 is on the circle, which it actually is. I just did the math in my head. We're going to show that the radius is in fact 5. Now, what we're going to do is that we're saying that this is the radius. All right. What we're going to do is that we're going to create a right triangle, essentially like we're doing rise over run. All right. So in other words, we're going to do it like that. Now, you may be able to see the lines, you may not be able to see the lines. But essentially, just for reference, these are where the unit lines are. At least the ones that we care about. All right. So, my question to you is, what's the length of this side right here? So I would just count how many units there are between this point and this point. There's 5. Well, actually, there's 4 because you'd have to go 1, 2, 3, 4. So it'd be 4 right here. What about right here? What do you think the distance is? 3. So now we're going to put it in the Pythagorean theorem. So we're going to do a squared plus b squared is equal to c squared. So I got 4 squared plus 3 squared is equal to c squared. That's 16 plus 9 is equal to c squared. 25 is equal to c squared. Take the square root. What's the square root of 25? 5. So 5 is in fact our radius. So if I ever ask you if the center is this and a point on the circle is this, you would literally, you can either graph the points in Desmos to kind of figure out what the right triangle side lengths are, or you can use graph paper to do it. But this is how you would set it up essentially. All right, you would do rise over run to get your 2 side lengths, put that in for A and B in the Pythagorean theorem, and then solve for C. Does that make sense? All right. Okay. Last thing. So just some review from yesterday. So for a couple of these questions, we're going to figure out what the center point is and what the radius is. All right. So recap. Remember, this is the formula. All right. So if the center point, let's say the h value is negative in the equation, that means the h value of the point is what? So if this h value is negative as it is right now, that means when we put it in the point, it'll be what? Positive, because that's part of how the equation's set up. Now, if it was positive, that means the point it'll be what? Negative. All right. So for letter A, yes. So for letter A, someone raise their hand and tell me my center point. Gavin. Good. So 5, 2. Here's my H, here's my K. And since they're both negative, that means they're both positive within the actual point. Now, with the radius, remember in the equation, it's written as r squared. All right, so it's the square of the radius in the equation. So someone different, raise their hand and tell me what my radius is. Jasmine. 5. You would have to take the square root of 25, and that would give us our radius. All right, let's do another one. Someone new, raise their hand and tell me the center for letter B. Corey. -4, +1. Good. Someone different, tell me what the radius is. Tomas. Say it again. 10. Sorry, I couldn't hear you over the fan. Good. If you took the square root of 100, that would give us 10. All right. Someone new, tell me what the center is for letter C. Think carefully about it. So I'm guessing that x squared is what's throwing you guys, right? Now, we talked about this a little earlier. Yes. What do you think? There you go. So remember, with this x squared right here, if you have an x squared or a y squared by itself, that means that value of the point is 0. So this would be 0, +3. What would the radius be? Mariana. It'd be 1. Square root of 1 is also 1. All right. You guys feel pretty good about being able to find the equation of the circle and the center and radius and vice versa? All right. All right. So that's all the notes that we're doing for today. Now, there is a new delta math that we do have.